Continuing on with question number 4 from RACE-4 of the Secureum Bootcamp, it says that in the Secureum contract we have A, an increase allowance function that is susceptible to an integer overflow, and B, a decrease allowance function that is susceptible to an integer overflow. So we already know that both of these functions are indeed within the Secureum contract, even though they're not standard functions that are supposed to be in ERC20, they are still here. And we can see that we have indeed an addition that happens in the increase allowance function and a subtraction that happens in the decrease allowance function, which makes sense. But we have no unchecked block in either of these. And that means, since we are using solidity 0.8 in the snippet, that means that there is no chance for an overflow to happen here, and not even an underflow, even though the question didn't ask for that. So both the options A and B cannot be true just by that fact. Continuing with the option C, it says that decrease allowance does not allow reducing the allowance to 0. So let's take a look at decrease allowance. Here we can see when we want to decrease the allowance of a spender, we specify the subtracted value, which is the value by which we want to subtract the allowance of the spender by. We can see that first it loads the current allowance of that spender. It does this correctly in this case. It first specifies the owner in the first index and then the spender in the second index, just like all the other functions do or are supposed to do. And that means that it is correctly loading the current allowance, and then it checks, it requires the current allowance to be greater than the value that we want to subtract from that allowance. The problem with this is that if the current allowance is 10 and we want to decrease the allowance to 0, we would have to specify a subtracted value of 10, but it is not allowed to be equal. It's only allowed to be larger than, so we could only reduce it to one way, basically. And it is indeed not possible to reduce the allowance to 0, just as point C suggests. Therefore, C is indeed correct. Then we have point D, which says that the decrease allowance function can be optimized with an unchecked block. So the decrease allowance function, the only place where an unchecked block would make sense here would basically be right here where the subtraction happens. Because we are in 0.8, Solidity would automatically add protection against underflows during this subtraction here. But this protection, it costs extra gas because it needs to check the result, whether the result has underflown, basically. And this check is not necessary because we already have this check explicitly here in this require. Even if we correct it to be bigger than and equal to, this current allowance would always be large enough so that no matter what subtracted value is, if it reaches this code, it would never be larger for the result of the subtraction to actually underflow, because the maximum that subtracted value could be is equal to current allowance. So the worst it can get, the worst possible value, if we put it that way, is 0. It can never go below 0, basically. So indeed, we could optimize this code by putting this subtraction into an unchecked block and therefore saving one check against underflows that Solidity would add to this, and therefore saving just a little bit of gas. So indeed, the decrease allowance can be optimized with an unchecked block is also true. And that was question 4.